Predict viral pandemics using AI and flight data. Imagine, if you will, a global game of whack-a-mole, but the moles are invisible. They carry genetic code that can upend civilization, and our only mallet is a tangled mess of bureaucracy and reactionary policies. For decades, our strategy against viral pandemics has been fundamentally retrospective. See a mole, whack a mole. But what if we could peer into the future? What if we could see the moles beginning to stir in their burrows, track their potential paths through the world's tunnels, and have a mallet ready and waiting before they even poke their heads into the sunlight? This is no longer the stuff of science fiction. By harnessing the seemingly mundane power of artificial intelligence and global flight data, we are on the cusp of turning pandemic response from a frantic game of reaction into a discipline of sophisticated prediction. The concept is as brilliant as it is, when you think about it, obvious. Viruses don't have frequent flyer miles, but the people who carry them certainly do. The modern world is woven together by a breathtakingly complex web of aviation routes. Every day, thousands of aircraft crisscross the globe, creating a real-time map of human connectivity. This network is the superhighway on which a local outbreak can become a global crisis in a matter of days, as we've witnessed with heartbreaking clarity. But this vulnerability is also our greatest asset. Flight data provides a live feed of the potential pathways a virus could take. It's the digital nervous system of our planet, and we've finally learned to listen to its signals. Enter artificial intelligence, our digital Sherlock Holmes, equipped with a magnifying glass the size of the internet and a capacity for deduction that would make the great detective blush. AI, particularly machine learning models, excels at one thing: finding patterns in chaos. We can train these models on a rich historical stew of data. Past outbreak epicenters, the flight routes active from those regions at that time, and the subsequent spread of the disease to new cities. The AI isn't just looking for direct flights from point A to point B. It's discerning the subtle, high-risk connections, the multi-hop journeys, the major hub airports that act as powerful amplifiers, and the seasonal fluctuations in travel that might funnel a virus toward a large gathering. The process is both elegant and, in a way, comically analogous to a paranoid royal food taster from history. Think of the AI as the ultimate hypochondriac for the entire planet. It constantly samples a worldwide buffet of potential threats. An unusual cluster of pneumonia cases in a hospital database here, a spike in searches for flu symptoms or sales of cough medicine there, a report of a sick animal cluster in a wet market elsewhere. This is the now-casting piece of the puzzle. Then it spins around, looks at the live flight tracker, and says, right, 10 people from that city just got on a plane to Frankfurt, and 5 more are connecting to Sao Paulo. Frankfurt has a connecting flight to New York departing in 2 hours. Sound the alarm for Germany, Brazil, and JFK International. The comical aspect lies in the data points it might initially consider before learning what truly matters. Early in its training, an AI model might, with utter seriousness, try to correlate pandemic spread with a region's consumption of a particular brand of soda or the popularity of a catchy new pop song. It's a classic case of correlation without causation, the machine learning equivalent of a conspiracy theory. The crucial human oversight comes in guiding the AI, in teaching it that while the number of flights from Milan is critical, the fact that everyone in Milan was listening to a certain Eurovision Song Contest winner is probably just a delightful coincidence. The potential of this synergy is staggering. Instead of blanket travel bans, a blunt instrument that causes immense economic and social collateral damage, we could implement hyper-targeted smart containment. Health resources could be pre-deployed. Airport screenings could be focused with laser precision on specific flights from specific origins, rather than creating chaotic, performative security theater for all arrivals. Vaccine and antiviral development could be triggered earlier, aimed at the most likely threats, shaving precious months off our response time. We could move from a strategy of global lockdown to one of strategic, localized defense. Of course, this powerful tool is not without its perils. The path is littered with ethical banana peels. Privacy concerns are paramount. This system must be designed to analyze anonymized, aggregated data, not to track individuals. We must also guard against the creation of a modern-day scourge of God, label being digitally assigned to certain regions, leading to stigmatization and economic prejudice. The data and the algorithms must be transparent and available to the global community to prevent a new form of digital colonialism, where only the wealthiest nations get the predictive advantage. The vision is clear. We are no longer helpless observers to the emergent patterns of biology. By marrying the cold, calculating logic of AI with the dynamic flow of human movement captured in flight data, we can build a planetary immune system. It's a system that detects the infection early, identifies how it might spread, and marshals its defenses proactively. It's about replacing the panic of the whack-a-mole arcade with the calm, strategic foresight of a grandmaster moving pieces on a global chessboard. The moles will keep coming. That is an evolutionary certainty. But we no longer have to wait for them to pop up. We can finally, brilliantly, start predicting their moves. If you found this video informative, please like and subscribe. It will really help this channel out. Thank you for watching. Stay tuned for more informative videos coming.